All right, so today we're going deep on cloud security. But we're not just talking about the basics. We're really getting into how machine learning is being used to protect your data in the cloud. Kind of like digital bodyguards, but they're all powered by these algorithms.
Mhm.
And we have this research paper you sent over a review of machine learning based security in cloud computing. We're going to try to break down the important parts for you.
Yeah, and I think what's really interesting here is it's not just about like adding on more security measures. It's really about how we can use machine learning to, meet the challenges of the cloud itself.
Yeah, that's what I thought was really interesting too. So let's talk about those challenges for a minute. One of the big ones right away is this idea of shared responsibility, right? Like with infrastructure as a service, you're basically renting the building blocks, but you're still the one responsible for securing everything you build on top of it.
Exactly. And that could be kind of tricky because you may not have the same visibility or control, that you would have with a traditional setup. It's almost like you're building a fortress on someone else's land. You have to make sure that the foundation is solid, but you also need to think about your own defenses too.
Right. And that leads to another challenge with these multi-tenant environments. I mean, in the cloud, you're often sharing resources with other organizations, and that obviously raises concerns about data isolation and preventing someone from accessing your stuff. It's almost like living in a big apartment building. You want to make sure that people can't look into your apartment or mess with your stuff.
Right. It's a valid concern, but
Yeah.
imagine you had like this security system that could not only tell when someone was trying to like break in,
Hmm.
but it could predict, who might be a threat based on like how they're acting. That's the kind of power we're talking about with machine learning.
Okay, so we're starting to get an idea of how this works, but what are the specific threats we're talking about here? The paper talks about things like SQL injection attacks, where hackers try to sneak in bad code into database queries. It also talks about all these virtual machine attacks, like replication attacks, where someone could essentially hijack your virtual machine and mess with your data.
Yeah, those are just a couple of examples, but
Yeah.
the main thing is in the cloud, all your virtual machines, your data, your whole setup, it's potentially open to all kinds of threats. It's like having a house with a ton of ways to get in. You need a security system that can keep an eye on all of them.
And that's where these machine learning algorithms come in, right? They can look at huge amounts of data and try to find those little patterns that might point to a threat.
Yeah.
And they can even respond to those threats immediately. It's almost like having a security system that's always learning and adapting.
Exactly. And because they can process information so much faster and better than humans, they can give you a level of protection that we couldn't get with the old ways of doing things. And they can also scale to handle the massive amounts of data that we see in cloud environments.
So it's not just about having more security guards. It's about having smarter security guards. But there are so many different machine learning algorithms out there. It's hard to know where to start. Can you maybe break down some of the important ones for us?
Sure, let's start with random forests. Imagine you have a bunch of security experts, each with their own way of looking at things and their own expertise, all coming together to decide if something is a threat. That's basically what a random forest algorithm does. It combines the predictions of a bunch of decision trees to give you a more accurate and well-rounded assessment of the security risks.
So it's kind of like a collective intelligence approach to security. What about decision trees themselves? They seem pretty straightforward.
Yeah, they are, at least in theory. You can think of a decision tree like a flowchart for security decisions.
Yeah.
It breaks a problem down into a series of yes or no questions that lead to a prediction or classification. Like, is this user accessing sensitive data outside of normal hours? Is this IP address known to be associated with bad stuff?
So it's a way to automate those initial security checks and flag anything that looks suspicious. The paper also mentions k-means clustering, which sounds a bit more complex.
It is, but it's also really powerful. Imagine you're trying to sort through a pile of laundry, but instead of clothes, it's network traffic data. K-means clustering lets you group together similar data points based on their characteristics. This could help you find clusters of malicious IP addresses or spot weird patterns of user behavior that might mean an account has been compromised.
So we're basically talking about grouping these potential bad actors together based on things they have in common. And that seems like it could be super helpful when you're trying to figure out where to focus your efforts, especially with so much data flying around in these cloud environments.
Yeah, exactly. And it's not just about like finding the threats, it's also about figuring out how they change over time. And that's where machine learning really comes in, because it can adapt.
Can you talk more about that? Like, how do these algorithms keep up with the hackers who are always coming up with new tricks?
Well, unlike those old school rule-based security systems, the ones that rely on like preset patterns, machine learning can actually learn and adapt as it goes. They can look at past data to spot trends and even try to predict future attacks.
So it's like a security system that's constantly getting smarter and more advanced.
That's the idea. And it's not just about reacting to threats anymore. It's about stopping them before they even happen. For example, they can look at network traffic for anything unusual. That might point to a potential attack. And this lets security teams take action before anything bad happens.
That proactive element seems like a total game changer. It's like having a crystal ball that can see cyber attacks before they happen.
Well, it's not quite magic, but it's definitely a big step forward. And it's not just about better security. It's also about making security operations more efficient. Like machine learning can automate stuff like looking at logs and finding threats, which frees up human analysts to focus on the really tough stuff.
That makes sense. It's like having an army of digital assistants working behind the scenes.
Exactly. And because they can work so much faster and more accurately than humans, they can cut down on all those false alarms, which can be a huge waste of time for security teams.
So it's not just about having more security, it's about having smarter security.
Exactly. And it's not even just about security. Machine learning can help you use your cloud resources better too, making sure you're only paying for what you actually need.
That's interesting. So it's playing a role in both security and efficiency.
Absolutely. And as the technology gets better, we're going to see even more ways to use it, from like personalized security that adapts to each user to systems that can heal themselves and fix problems automatically.
This is all really fascinating stuff. But before we get too carried away with all the possibilities, I wanted to go back to something you said earlier about needing lots of good quality data to train these algorithms. Can you talk more about that?
Sure. So machine learning algorithms are only as good as the data we feed them.
Hmm.
If that data is biased, incomplete, or just plain wrong, the algorithm is going to make bad predictions. It's like teaching a dog to fetch with a flat tennis ball.
So garbage in, garbage out, basically. That makes sense. Are there any other limitations or challenges we should be aware of?
Well, another one is that some of these models are really complex. Some algorithms, especially the really advanced ones, are hard to understand. Like it can be tough to figure out why it made a certain decision. And that's a problem in security, where we need to be able to explain things and hold systems accountable.
So it's like having this black box making security decisions. That can be a little unnerving.
Yeah, I get it. That's why it's important to think about that trade-off between how powerful the algorithm is and how easy it is to understand. You want something that can stop threats, but you also need to know how it's doing it.
And that brings up another question. What are the ethical implications of using machine learning for security? I mean, these algorithms are making decisions that could have real consequences for people and businesses.
That's a really important point. As these algorithms become more powerful and independent, we need to be careful about bias discrimination and unintended consequences.
Yeah.
We have to make sure these systems are designed and used responsibly and ethically with the right safeguards in place.
It's like we're moving into this new era where we're trusting machines to make crucial decisions about our security and privacy.
Exactly. And with that trust comes a responsibility to make sure those decisions are made fairly and transparently. With humans keeping an eye on things, we need to think about the values that are built into these systems and the impact they could have on society.
It's a complicated landscape, but definitely a fascinating one.
Yeah, it really feels like we're at this turning point in how we think about security in the cloud.
I think so too. We're moving away from just reacting to attacks after they happen and trying to clean up the mess and going towards this more proactive approach where we use machine learning to like anticipate and stop threats before they can even cause any damage.
It's almost like we're building some kind of digital immune system for the cloud. It's constantly learning and adapting to new threats. But like we've talked about, there are definitely challenges and ethical things to consider.
Absolutely. We have to be careful about bias in the data and how complex these algorithms are and the possibility of someone trying to trick them. And we really need to have these open conversations about the ethics of using machine learning in security.
So what does all of this mean for like the average person who's using cloud services? Like what should they be thinking about or asking their providers to make sure their data is actually safe? That's a great question. I think the most important thing is to understand that shared responsibility model, like know what your provider is taking care of and what you need to do to protect your own stuff.
So don't just assume they're handling everything right. Be proactive and ask questions.
Exactly. And don't be afraid to ask them about how they're using machine learning for security. Like what algorithms are they using? How are they dealing with potential bias? What are they doing to make sure these technologies are being used responsibly?
Transparency is so important. We need to be able to trust the systems that are protecting our data.
For sure. And as users, we also have a responsibility to stay informed. About the latest threats and best practices. Machine learning is powerful, but it's not a magic solution. We still need to do the basic things to protect ourselves, like using strong passwords and having multi-factor authentication and being aware of phishing scams.
It's a team effort. We all have a role to play in making the cloud a safer place.
Well said. And as machine learning gets even better, we're going to see some really innovative security solutions. It's a really exciting time to be working in this field, and I'm confident that we're going to see some amazing progress in the coming years.
This has been a really fascinating deep dive into the world of machine learning and cloud security. Thanks so much for sharing your expertise with us.
It's been my pleasure. And remember, knowledge is power, especially when it comes to cybersecurity. Stay curious, stay informed, and stay safe out there in the cloud.